Hello everyone, welcome back to Question with Answer. This is NumPy Interview Questions and Answers, Part 2. In Part 1, we covered NumPy basics like arrays, shape, type, broadcasting, and reshaping. In this video, we'll move to the next level, focusing on indexing, slicing, Boolean masking, mathematical operations, and axis-based calculations, topics that are very frequently asked in interviews. So make sure you watch till the end, and let's get started. Question 1. What is indexing in NumPy? How is it different from Python list indexing? Answer. Indexing in NumPy is used to access specific elements from an array. While it looks similar to Python list indexing, NumPy indexing is far more powerful. In NumPy, you can access elements using integers, slices, arrays of indices, or Boolean conditions. Unlike Python lists, NumPy supports multidimensional indexing, allowing direct access to rows and columns in 2D arrays. This makes data manipulation faster and cleaner, especially in data analysis and machine learning tasks. NumPy indexing avoids nested loops and enables vectorized data access, which improves performance and readability. This code accesses an element from a 2D NumPy array using row and column indices. It directly retrieves the value without looping. Question 2. What is slicing in NumPy arrays? Answer. Slicing in NumPy allows you to extract a portion of an array instead of accessing a single element. It follows the format, start, end, step. NumPy slicing works on both one-dimensional and multi-dimensional arrays. One important interview point is that slicing returns a view, not a copy. This means changes made to the sliced array can affect the original array. Slicing is widely used in data preprocessing, feature selection, and time series analysis. NumPy slicing is faster and more flexible compared to Python lists, especially for large datasets. This code extracts elements from index 1 to index 3, demonstrating how slicing retrieves a subset of the array. Question 3. What is Boolean indexing in NumPy? Answer. Boolean indexing is a powerful feature in NumPy that allows filtering array elements using conditions. Instead of accessing elements by index, you use a Boolean expression that returns true or false. This technique is commonly used in data analysis to filter records, remove outliers, or apply conditional logic. Boolean indexing eliminates loops and makes the code concise and efficient. In interviews, Boolean indexing is often tested because it shows how well a candidate understands NumPy's vectorized operations. This code filters and returns only those elements that satisfy the condition greater than 20. Question 4. What is fancy indexing in NumPy? Answer. Fancy indexing is used when we pass a list or array of indices to access multiple elements at once. Unlike slicing, fancy indexing always returns a copy, not a view. It is useful when you want specific non-contiguous elements from an array. Fancy indexing is commonly used in machine learning datasets where selected rows or columns need to be extracted. Understanding the difference between fancy indexing and slicing is an important interview topic. This code extracts elements at specific positions using a list of indices. Question 5. How do NumPy mathematical operations work on arrays? Answer. NumPy supports element-wise mathematical operations such as addition, subtraction, multiplication, and division. These operations are vectorized, meaning they operate on entire arrays without loops. This results in faster execution and cleaner code compared to Python lists. NumPy also provides universal functions like np.sqrt, np.exp, and np.log. Mathematical operations on arrays are heavily used in machine learning, data transformation, and scientific computations. This code applies a mathematical function to each array element simultaneously using vectorization. Question 6. What is the use of axis in NumPy operations? Answer. The axis parameter defines the direction along which an operation is performed. In a 2D array, axis equals 0 means column-wise operations, and axis equals 1 means row-wise operations. Understanding axis is critical for aggregation functions like sum, mean, max, and min. Many interview candidates get confused here, making it a favorite interview question. Correct use of axis simplifies data aggregation and avoids manual looping. This code calculates the sum of each column using axis equals 0. Question 7. What is the difference between NumPy.sum and Python sum? Answer. Python's built-in sum works on iterable objects but is slower for large numerical data. NumPy.sum is optimized for NumPy arrays and supports the axis parameter. NumPy.sum performs faster computations because it is implemented in C and supports multidimensional aggregation. In interviews, candidates are expected to prefer NumPy.sum when working with arrays. This code calculates row-wise sums using NumPy's optimized function. Question 8. What is NumPy.where, and how is it used? Answer. NumPy.where is used to apply conditional logic to arrays. It returns elements based on a condition and supports if-else style operations. It is widely used for data cleaning, feature engineering, and conditional value replacement. This function avoids loops and keeps code efficient and readable. Interviewers often ask this question to test conditional logic handling in NumPy. This code assigns values based on a condition using vectorized logic. Question 9. What is NumPy.unique used for? Answer. NumPy.unique returns the unique elements from an array and optionally provides counts. It is useful for data analysis, especially when identifying distinct values or categories. This function is often used in exploratory data analysis and preprocessing tasks. Interviewers expect candidates to know how to extract unique values efficiently. This code removes duplicate values and returns only unique elements. Question 10. What is the difference between flatten and revel? Answer. Both flatten and revel convert a multidimensional array into a 1D array. The key difference is that flatten returns a copy, while revel returns a view whenever possible. This difference matters when working with large datasets and memory optimization. Interviewers often ask this to test understanding of memory management. This code converts a 2D array into a 1D array using a memory-efficient method. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.